In this video, we're going to talk about linear approximation. And by the end of the video, I feel that you're going to easily be able to estimate some of the problems shown here. Now, folks, in my opinion, there's a lot of mathematical notations here that tend to confuse things. So if you're looking through your notes right now from class, you may see notations such as this shown here. But I'm going to try to demystify this and take away some of this language, some of this mathematical notation, and talk about what you really need to do to solve these problems. The first thing you need to do is identify what function you're working with. What is your working function? So here, if you're asked to estimate 2.21 squared, your working function is f of x equals x squared. Here, the working function would be tangent of x. And finally, this would be x to the 1/4 power. So the problem with what you're presented with is these are not easy to work with these particular given functions. So the first thing you want to do is choose what I call an easy A. All right. So this is the A that you see in your mathematical notation in your classwork. And I'm going to refer to that as the easy A. So you want to pick an input value, we're going to call it A, that makes these particular functions easy. So for the first one, our easy A is going to be 2, because 2 squared is easy. 2 squared is 4. So our A value is going to be 2. For the next one, our easy A value is going to be pi over 4. Because it turns out, as we'll see in a minute, that the tangent of pi over 4 is 1. And finally, for the last one, we're going to choose an easy A value of 16, because 16 to the 1/4 power is simply 2. Now, these easy A's were not randomly chosen. Specifically, they are not only easy, but they are in close proximity to what we were presented with. Folks, the whole key to these problems is as follows. We need to establish a tangent line to the specific functions that we're working with. Now, why is it important to get a tangent line? Because once you have the equation of a line, it doesn't matter what x input you are given. Whether it's easy or hard, you can get the y value, and that's what we're interested in. So for example, if you're presented with the equation of this line, if you are given the point x equals 2, then f of 2 is simply going to involve plugging in 2 for x right there. So we're going to do y equals 4 times 2 minus 4. That's going to be 8 minus 4 is going to be 4. So your f of 2 in this particular situation is easy. However, this line, equation of the line, will also allow you to get the y value even if the x value you're putting in is a little bit more difficult. Like let's say you plug in 2.21. Now it's not as easy as the first one, but ultimately if you plug in 2.21 here, it's just multiplying and subtracting. It is not as difficult as taking the tangent of a difficult number or squaring a difficult number. So again, the key to these problems is to find the equation of the line that you're going to use to do your problem. Now, equations of a line come in different forms. Slope-intercept form is the easiest. We're used to working with that. But the problem is here, the problems we're working with, you're not given the y-intercept. So we're not going to be using this. What we're going to be using is the point-slope form. Not as comfortable, not as familiar, I'll grant you that. But to me, part of the problem is this mathematical notation with the y1, x1. You don't know what is which is what. So I'm going to make a small variation to the point slope form as follows. First thing I'm going to do is instead of y1 and x1, I'm going to change that to yp and xp. And that's going to be the x and y values of the point that you have. And what point are you going to have? You're going to have the a value, the easy a value that you pick, and you're going to have f of a, which is going to be easy because you're going to pick an a value that's easy to get f of a. So for example, if your working function was y equals x squared, we're going to pick a equals 2, and your f of a, when you plug in 2, you're going to get 2 squared is 4. We're going to have a point. You're going to pick a point in essence. So that's the y and the x you're going to be working with in this video. So change that 1 to p. That's the point that you have. Now the second small change I'm going to make is as follows. I'm going to move this over like so. And I'm going to take this minus yp, which is on the left side of the equation, and I'm going to put it on the right side, and I'm going to change the sign to positive, like so. All right, let me rearrange this a little bit. So thank you for your patience. All right, so before I forget, I'm going to change that y to a positive, and I'm going to put a plus here. This is the form that I want you to work with. So if we have this point right here, we picked an easy a. We got f of a, which is going to be easy. Now you're going to plug in the points into the point slope form. Now you have to be careful with the x. See that minus? That means whatever we have here, we're going to do the opposite. So the formula we're going to be working with is y equals 4 plus m times x minus 2. And now the only thing left to do is find the slope of our line. And to do that, we're going to take the derivative, because that's how we find the slope of the tangent line. We're going to take the derivative of our function, and then we're going to find the slope using our easy a value right there. So we're going to do f prime of easy a. And once we get our slope, the ball game is over, because now we have an equation of a line. And once we have the equation of a line, admittedly, our version is going to be in point slope form. It's not going to be as easy as this. But once we have the equation of our line in point slope form, then you can plug in any x value and get your y value. And that's what we want. Ultimately, we want the y value of the difficult x input. And in the end, we're going to be calling that L of x. Let's now go ahead and use linear approximation to estimate 2.21 squared. Our working function, f of x, is going to be x squared. I went ahead and drew that here. Our next step is to pick an a value that's easy and relatively close to 2.21. So our easy a value is going to be right here, a equals 2. Immediately, we're going to go ahead and get f of a, because we're going to need that. So f of a means we're going to plug 2 into our working function, and we're going to get 4. So folks, we already have our point. Our point is going to be 2 comma 4. Okay. Now, let's go ahead and write our point slope formula. Point slope formula is going to be y equals the y value of our point plus the slope times x minus the x value of our point. We already have our point, so we're going to go ahead and plug it in. So y is going to equal 4 plus m x minus 2. And the final thing we're going to do is we're going to change that y to L of x. Okay, so here's our L of x. It's going to be a tangent line that we're going to bring in right there. That line is L of x. Okay, now, we don't have the formula for L of x yet. We need the slope. How do we get the slope of that line, that tangent line? Well, we take the derivative and we plug in our easy a value to give us our slope. So our slope, this slope is going to be f prime of easy a. This is our function up here. F prime of x squared is going to equal 2x. We're going to do f prime of a, easy a, and that's going to be, that's going to be 2 times our easy a value, or 2 times 2, or 4. So our slope is 4. So we're going to go ahead and plug that right in, and we have our equation for L of x. So 4 plus 4 times x minus 2. So what does that mean at this point? That means you can give us any x value, and we can plug it into this formula, and it will give us L of x. So any x value you give us, okay, in this case, they're giving us 2.21. So we're going to go ahead, we're going to plug 2.21 into the equation of this line, and that's going to give us this L of x value right there. And what we're arguing is that L of x value, which we can compute easily, this is just multiplication and subtraction, is going to be close enough to f of x. So this would be f of 2.21 or 2.21 squared. And our argument is that this L of x value right here, whatever it is close enough to that value. Okay, so let's go ahead and excuse me, find L of x. We're going to plug in 2.21 here. We're going to end up with 2.21 minus 2. So 4 plus 4 times 0.21. And when all the smoke clears, when we do all the math, we're going to end up with a value of 4.84. Now, if we went ahead and plugged in, actually, 2.21 squared in a calculator, we would end up with 4.88. So let's review what we did. We were given f of x equals x squared with a difficult x value. We chose an easy x value. We used our function to find the y value. So now we have a point. In order to get the equation of a line using point-slope form, you not only need a point, which we have, 2, 4, you need a slope. How do you get the slope? You take the derivative and you plug in your x value. We took f prime of x here, we plugged in our x value, that's our easy a that we plugged in, we got 4. So now we have a slope and a point, we have a line in point-slope form. Now, any x value you give us, difficult or not, we can plug it into that formula and get the L of x value. And our argument is that this L of x value is close enough to 2.21 squared, and we proved that because we got 4.84 versus 4.88. In our next example, we're asked to find the tangent of pi over 4 plus 0.01. That means our working function, f of x, is going to be tangent of x. Our first move is to pick an easy a value. We're going to choose pi over 4. Immediately, we're going to get f of a because we want a point. We want our point, x of p, y of p, to create the point-slope formula for our tangent line. F of a means we're going to plug in easy a into this working function. Let's go to the unit circle. This is pi over 4, 45 degrees. Note it's halfway between 0 and 90 degrees. The way I like to teach this is I call this value medium, square root of 2 over 2, and this value medium, square root of 2 over 2. The tangent of 45 degrees, the tangent of pi over 4 is going to be the sine value over the cosine value, which is going to be 1. So folks, we already have our point, we already have our point, and we're using the point slope formula. So now we need to get our slope. Let's go ahead and write the point slope formula. It's going to be y equals y sub p, which we already have, plus the slope times x minus x p, which we already have. Let's plug in what we already have. We have y equals our y value of our point, our easy a, and we do not know the slope yet, but we do know the x value of easy a. Okay, I'm going to erase some of this now, and now let's go ahead and get the slope of our tangent line. How do we do that? We take the derivative and we plug in an x value to get the slope of the tangent at that x value. If our function is tangent of x, then f prime of x equals secant squared x. We want f prime of easy a. So we want secant squared of pi over 4. So let's talk about the secant of pi over 4. We're still at pi over 4 here on our unit circle. The secant is 1 over the cosine. Our cosine is the x-coordinate of the unit circle. So if our cosine is square root of 2 over 2, the secant is going to be 2 over the square root of 2. That's the secant of pi over 4. We want secant squared. So we're going to take this and multiply by itself. And we're going to end up with 4 over the square root of 4, which is 2, or 2. So the slope at a, that's what this means. F prime of a is the slope at easy a. That value is 2. So we're going to go ahead and complete our tangent line. 2 times x minus pi over 4. And then we're going to rename that L of x. And this is the formula that we're going to use now to find, to estimate the tangent of pi over 4 plus 0.01. So let's go ahead and make some room. And proceed to plug in an x value here. This difficult x value is now being placed into our linear function. That's the idea, to use the easier function, which is linear. So we're going to have pi over 4 plus 0.01 minus pi over 4. This is going to give us 1 plus 2 times 0.01. It's going to be 1 plus 0.02. Sorry, that's messy. Let me redo that. 1 plus 0.02, or a final answer of L of x equals 1.02. In our next example, we are asked to find e to the 0.1. So our working function is f of x equals e to the x. Recall, e to the x is a growth function, which means as you move from left to right, it moves away from the horizontal asymptote, which is 0 in this particular problem. Folks, the first thing we're going to do is pick an easy a value. So you could see e to the 0 power is just 1. So we're going to choose an a value of 0. We're immediately going to find f of a, which we just said was 1, right? E to the 0 power is 1. Now we're going to build our tangent line equation. Our modified point slope form is y sub p plus mx minus x sub p. But folks, we already have our point. Our point, x sub p, y sub p, is 0, 1. We're going to go ahead and plug that in. So we're going to have y equals 1 plus m times x minus 0, otherwise known as 1 plus m times x. We are now going to rename that function as L of x. Okay, our next move is to find the slope. The slope of the tangent line when x equals 0 will be f prime of a, f prime of easy a, which is 0, and f prime is none other than e to the x. So we're going to have e to the 0 or 1. So our L sub x is going to equal 1 plus 1 times x. This 1 came from our slope. Now, all we need to do, folks, is plug in the x value that they want us to estimate. And that value is 0.1. So we're going to come down here, we're going to say 1 plus 1 times 0.1, and our final value is going to be 1 plus 0.1 or 1.1. And if you look at our graph, you could see if we plug in 0, we get a value of 1 for our y value. If you go a little bit further, 0.1, we end up at 1.1. Next, we are asked to estimate the natural log of 1.04, which means our working function is going to be the natural log of x. Recall, the natural log function is the inverse of the e to the x growth function. So it has a vertical asymptote at 0 and runs like so. So natural log of 1.4, here is 1. The natural log of 1 is 0. So we're looking at this part of the graph. So we anticipate this should be a little bit more than 0. Excuse me. Folks, the first thing we do is we pick an a value. And we're going to choose a equals 1. Immediately, we're going to get f of a. So f of 1 is the natural log of 1, and we already said that was 0. We have our point. Let's go ahead and build our point slope equation. We're going to have y equals y sub p plus m times x minus x sub p. This is our point. We're going to go ahead and plug in 0 for y sub p. The m we don't have yet. And we're going to have x minus 1. And we're going to rename this function as L of x. So cleaning up, we have L of x equals m times x minus 1. Okay, let's proceed to find the m value. The slope of the tangent line is going to be f prime of the easy a, which means f prime of x equals 1. We're going to go ahead and take the derivative of ln of x. So if we apply the derivative operator to natural log of x, we're going to get 1 over the argument times the argument prime, which in this case is 1, times the natural log of the base. Natural log of e is 1. So this is our derivative. We're going to go ahead and do f prime. That's our f prime. We're going to do f prime of 1, and we're going to get 1 over 1, or 1, as our slope. We're going to rewrite L of x as 1 times x minus 1, otherwise known as x minus 1. Now, this is our ln of x. So our tangent line, if we were to jump to the graph here, looks something like that. So what we want to do is we want to find the natural log of 1.04. So 1.04 is going to be about here. We're going to figure out what the value is on our tangent line, and it's going to be very close to what it would be on the actual natural log function. So if we plug in 1.04 in for x, right there, our L of x value is going to equal 1.04 minus 1, or 0.04, which, as we predicted at the outset, is just above 0. In our next example, we are asked to estimate 1 over the cubed root of 25. So our working function is going to be 1 over the cubed root of x. Since I know at some point we're going to be taking the derivative, I'm going to change this to a fractional exponent, 1 over x to the 1/3, and then I'm going to bring that up into the numerator, so we're going to have x to the negative 1/3. All right, let's hold on to that for a little bit and proceed with picking our a value. So if this is our working function over here, we're going to pick an a value that's easy. So a equals 27 will make things easier. We're immediately going to do f of a because we want the y-coordinate of our point. So we're going to have 1 over the cubed root of 27. The cubed root of 27 is 3. So our y value is going to be 1/3. Folks, we already have the point that we need to create the point slope equation. So let's go ahead and get that started. We have our point slope equation is y equals the y value of our point plus m times x minus the x value of our point. We have y equals 1/3 plus the m value, we don't have that yet, times x minus 27. We now are going to rename this as L of x. All right, let's now proceed with obtaining our slope. And to do that, we take the derivative, and then we're going to do, that will give us f prime, and then we're going to find f prime at a, and a, recall, is the easy number of 27. So let's go ahead and take the derivative of this. So we're going to have negative 1/3 x, and negative 1/3 minus 1 is negative 1/3 minus 3/3, or negative 4/3. All right, so let's simplify this. Let's change this to negative 1 over 3 times x to the negative 4/3 over 1. Let's now bring this into the denominator, and when we do that, we're going to change the sign of the exponent. So let me bring this down like so. Bring it down in the denominator. Let's be clear that that's in the denominator. We're going to change that to positive 4/3. Now let's go ahead and put this into a radical form. So here's our radical. Here's our x. Now the question is, what goes in that root position? Is it the 4 or the 3? And the way I remember it is, I think of this fraction as a plant. Okay, so here's our plant. We have 4 on top of the ground and 3 below. That's where the roots are, below ground. So that's the root. And the exponent is 4. Now another way to write this is to take this 4, flip it out, and put parentheses around the radical. So you end up with the cubed root of x raised to the 4th power. And this is how I prefer to have it, like this. To me, it's easier to evaluate when you plug in for x. Okay, so we have our derivative. Now what we're going to do is go ahead and let's be careful we put this in the right spot. So this goes in the denominator as the cubed root of x raised to the 4th power. Okay, so that's our f prime. We want f prime of a. We're going to put our easy a in here for x. So we're going to have f prime of easy a 27 is going to be negative 1 over 3 times 1 over the cube root of 27 raised to the 4th power. The cube root of 27 is 3. So we're going to replace this whole inside with 3. And then we're going to raise 3 to the 4th power. This is 3 to the 1st power. So we're going to end up with negative 1 over 3 to the 5th power. And 3 to the 5th power is 243. So our f prime of a is going to equal negative 1 over 243. We have everything we need now to build our fraction. And I promise I'm not going to put you through all this math. All right, so here is, we're going to put this value right there. So let me rewrite this a little bit larger. Our L of x, otherwise known as the equation of the tangent line, is 1/3 plus negative 1 over 243 times x minus 27. Folks, we are ready to go ahead and plug in what they want us to estimate. They want us to estimate when x is 25. So we're going to put 25 right into here. And when all the smoke clears, we get an L of x equal to 83 over 243. Crazy. In our next problem, we are asked to evaluate the secant of pi over 4 minus 0.02 quantities squared. So let's identify our f of x as f of x is going to equal the secant of x quantities squared. First thing we're going to do is we're going to pick an easy x value. So instead of what they presented to us here, our a value is simply going to be pi over 4. We're going to find the f of a value first and begin to build our L of x equation. So if we have the secant of pi over 4 squared, let's see where that takes us. We go to the unit circle. We're going to look at pi over 4 again. We saw that earlier in the video. Pi over 4 is going to have an x coordinate and a y coordinate of square root of 2 over 2. The secant is the reciprocal of the cosine. Here's your cosine value. So our secant value of pi over 4 is going to be that fraction flipped, or 2 over the square root of 2. Because we're squaring it, we're going to multiply it by itself. We're going to get 4 over the square root of 4, which is 4 over 2, which is going to be 2. So folks, we already have our point. Our point is going to be pi over 4, comma 2. Let's go ahead and start building our equation of L of x. We're going to have y equals the y value of our point times m times x minus the x value of our point. Y equals 2, that's the y value of our point, plus m, we don't have that yet, x minus pi over 4. Okay, let's now go ahead and proceed and find our m value. To find the m value, we need to take the derivative and plug in our easy a value of pi over 4. So let's take this function here and take its derivative. So f prime of x, let me bring this down here. F prime of x is, we're going to use the power rule, so we're going to have 2 times the secant of x, and then we're going to use the chain rule because that's within a parentheses, and the derivative of secant is secant tangent of x. Secant x tangent x, like so. Okay, we now are going to go ahead and do, that's our f prime. We're going to do f prime of our value that we picked, which is pi over 4. All right, so let's do our unit circle again. Here's our pi over 4. We have square root of 2 over 2 and square root of 2 over 2. Our secant value is going to be 1 over the cosine. The cosine is square root of 2 over 2. So this is going to be 2 over the square root of 2 times 2 over the square root of 2. And the tangent of pi over 4 is the y value over the x value, otherwise known as the sine value over the cosine value, and that's going to be 1. Very fortuitous. So on the top, we're going to have this 2 times that 2 times that 2, which is going to be 8. And on the bottom, we're going to have the square root of 4, which is 2. So our slope at pi over 4 is going to be 4. So I'm going to go ahead and I'm going to replace the m letter in our equation, which I forgot to name L of x. And I'm going to bring that 4 right there, and that is our L of x equation. We can use that to evaluate any x that they give us as long as it's near pi over 4. Here we go. We're going to take the x value that they want us to evaluate, and we're going to plug that right in there. So we're going to have, we are now dealing with a linear function, no more secants. So we're going to have pi over 4 minus 0.02 minus pi over 4, and that ends up being 2 plus 4 times negative 0.02. And when you evaluate all of that, you're going to get 2 minus 0.08, or 1.92 is the final L of x value. In our next problem, we are asked to estimate the square root of 96, which means our working function f of x is the square root of x. Folks, let's remind ourselves what we're doing here with this technique. So here, they want to know what the square root of 96 is. So if we plugged in 96 into our function, and we did f of 96, we would be here on the y-axis. So that is the square root of 96 right there, but we don't know what that number is. So here's what we're going to do instead. We're going to pick an a value close to 96 that's going to make our math easy, namely 100. And we're going to come up to our graph right there, and we're going to find the equation to the graph of the tangent line at that location, right there. That's going to be L of x. Once we find the equation of that tangent line using our a value and our f of a value, don't forget to create that equation. What we've been doing is getting an easy a value and then plugging that in to get our y value, and then using our point in this case 100 comma f of 100 as our point, and then we figure out the slope and we figure out the equation of that L of x line. Once we have it, we take the x value they give us, which is 96, we plug that into our L of x equation, and it gives us a number on the tangent line for an x value of 96. This right here, this asterisk, that is L of 96. And we're arguing that that value, which we achieved from the tangent line, is close enough to the value of 96 at the function to be acceptable. Okay, let's go ahead and redo the math now that we've been doing for the last several problems. First thing we're going to do is we're going to pick an easy a value. All right, we already alluded to it. We're going to choose a equals 100. F of a is going to be f of 100, which is the square root of 100, which is 10. So our point is going to be 100 comma 10. Let's build our equation of the tangent line, otherwise known as L of x. We already have our y point and our x point. So we're going to change this to L of x, and we're going to put our y value here. Here's m. We don't have that yet. And we're going to have 100 as our x value. Folks, let's now go ahead and take the derivative of our function, and then we're going to plug in a equals 100 and get f prime of a and get our slope. The f of x equals square root of x is easier to take the derivative if we change that to a fractional exponent. That becomes 1/2 x to the 1/2 minus 2/2, or negative 1/2. Reviewing how to simplify this, we have x to the negative 1/2 in the numerator, 1 in the denominator. I'm going to bring this down and change this to 1 over 2 times x to the 1/2 power, and then I'm going to rewrite this as a radical, which is the square root of x. That's our derivative. We are now going to take f prime of a. Our a value that we chose to make life easier was 100. So we're going to have 1 over 2 times the square root of 100, 1 over 2 times 10, or 1 over 20. That is the slope of the tangent line when x equals 100. So we're going to substitute that into there. We now have the equation for L of x. Folks, now we're going to take the x value they give us. We are going to take 96 and put it into our equation of our L of x. So we're going to get L of 96. So it's going to be 10 plus 1 over 20 times 96 minus 100 equals 10 plus 1 over 20 times negative 4. And when you do all of this math, you end up with L of 96 equals 9.8. In our next and final problem, we are asked to estimate 5.01 cubed minus 2 times 5.01 plus 3. So we're going to establish our working function of f of x equaling x cubed minus 2x plus 3. First thing we're going to do is pick an easy value for x. Let's use 5. We're going to call that our a value, or easy a value. We're going to do f of a, which is f of 5. We're going to plug in 5. We're going to have 5 cubed minus 2 times 5 plus 3, and I did that earlier, and that evaluates to 118. So folks, we already have the point that we need. We picked that a value to make our life easy. We got f of a, and that's 118. We are building the equation of the tangent to our graph. So we're going to have the following modified point slope formula. We have y of p. We have the x value of our point. So we're going to have 118 plus m, we don't have that, x minus 5. Okay, how do we get m? We take the derivative and we plug in our easy a value. So our derivative is going to be 3x squared minus 2. That is our f prime. We're going to do f prime of our easy a, and when we do that, we get 73. All right, because 3 times 25 is 75, minus 2 is 73. Folks, that is our m value. So we're going to have as our L of x function, okay, forgot to write that, L of x is going to equal 118 plus 73 times x minus 5. Now, no matter what x value they throw at us, we can get an estimate on L of x that we believe will be close to the original function at that difficult x value. Here, the x value they gave us was 5.01. We're going to plug in 5.01 in for x. We're going to end up with 73 times 0.01 plus 118. And you have to trust me on this, that our L of x value equals 118.73.